The EPA's multifamily high-rise program offers eligible buildings two paths to earning the ENERGY STAR. Both paths are required to follow the testing and verification protocols. This document can be found on the website, and we suggest having a hard copy available during this presentation. This webinar will provide you with an overview of this document. Parts 2 and 3 provide greater detail on each of the actual protocols. The testing and verification protocols establish a consistent set of requirements for the inspection, verification, and testing of components relating to the building's energy performance. The intent of the protocols is to verify that the construction documents and final building include all prerequisites, that measures installed perform as expected, and that, depending on path selected, all program requirements have been met. The protocols require documentation throughout the course of the project, beginning with plan reviews during the design stage. They also require that any change in design during construction be accounted for. The T&V protocols are intended to work in conjunction with the ENERGY STAR Multifamily High-Rise Simulation Guidelines, Performance Path, Prescriptive Path, Testing and Verification Worksheets and Photo Template, which are covered in other webinars. One of the principal objectives in the multifamily high-rise program is that all buildings earning the ENERGY STAR meet some minimum prerequisites. A prerequisites checklist is provided to easily summarize and document these requirements. All building components must comply with the specifications contained within the prerequisites checklist. During an inspection, if a building component is determined to be in non-compliance with the checklist, corrective action must be taken to bring the building into compliance. Otherwise, the building will not be able to earn the ENERGY STAR. If following the prescriptive path, the prescriptive checklist includes all prerequisites and is used to document program compliance. Another objective of the program is to ensure that not only the design of the building meets ENERGY STAR requirements, but that the constructed building also meets those requirements. In the performance path, if an individual building component is found to be performing at a less energy efficient level than that which was included in the proposed design model, one of the following actions shall be taken. Otherwise, the building will be ineligible to earn the ENERGY STAR. Option 1. Take corrective action to remedy the problem and bring the building component to the efficiency levels assumed in the proposed design model. Option 2. Allow the component to remain in its current condition, but the as-built energy model must be adjusted to accurately represent the condition. In any case, the as-built energy model must still demonstrate at least a 15% improvement over the baseline building. In the prescriptive path, if an individual building component is found to be performing at a less energy efficient level than that which was required in the path, one of the following actions shall be taken. Option 1. Take corrective action to remedy the problem and bring the building component to the efficiency levels required by the prescriptive path. Option 2. Allow the component to remain in its current condition, but the building can no longer follow the prescriptive path. An as-built energy model must be created to accurately represent the completed building, and the as-built energy model must demonstrate at least a 15% improvement over the baseline building. If neither option is pursued, the building will not be able to earn the ENERGY STAR. Before we review the actual T&V protocols, we'd first like to describe the overall process that should be followed in order to successfully comply with them. Depending on how you're viewing this presentation, the content in this slide may be too small to read. It can be downloaded from the website. The gray boxes indicate steps that the design team should take as they guide a building through the ENERGY STAR program, from design through construction and to completion. The blue boxes indicate a step where the EPA is involved, either because the design team is submitting documents to the EPA, or the EPA is giving the design team approval of completion or certification. Early in the design team incorporates prerequisites and requirements of the performance or prescriptive path into the design. When the construction documents are 75% complete, a full plan review using the T&V worksheets should be conducted and, if needed, corrective action taken to ensure the program requirements are represented in the documents. Often, a design team meeting with the architect and engineer present is needed to clarify program requirements and ensure CDs are revised correctly before they go out to bid. A second plan review at 100% CDs ensures that the program requirements are represented in the final plans. This plan review is documented using the T&V Worksheets and must be signed by a registered architect or professional engineer and submitted to the EPA for approval. Following the design stage but prior to construction, the licensed professional in charge of submissions should schedule a meeting with the general contractor, architect, and other key members of the project team to identify inspections and clarify expectations. The party responsible for conducting the testing and verification must stay in contact with the GC and architect to review applicable submittals and visit the site as necessary to conduct the required inspections. If needed, the project team must be notified of corrective actions to be taken to ensure that program requirements are met. Applicable corrections must be re-inspected to verify and document compliance. Post-construction and inspection, the T&V worksheets should be updated to reflect the as-built building and complete the photo template. The as-built model for the performance path must reflect any changes found during T&V. The designated licensed professional should sign and resubmit the final testing and verification worksheets to the EPA for approval. This includes the prerequisites checklist or prescriptive checklist and results of testing and verification. The photo template is also submitted at this time. If approved by the EPA, the building may be labeled as ENERGY STAR. Now let's review the protocols themselves. The T&V protocols cover all building components, starting with appliances, central and in-unit domestic hot water systems, above-grade and below-grade walls, roofs, floors, windows, exterior doors, and vestibules. Also included are garage heating and compartmentalization, central heating and cooling systems, and in-unit heating and cooling systems, as well as interior and exterior lighting and controls, emergency lighting, motors, envelope air sealing and total air leakage, common area and in-unit ventilation systems, and metering configuration. We won't be reviewing these in detail in Part 1. Rather, we'll take a look at the basic structure of the protocols and how they will streamline the inspection process and help ensure that the project successfully achieves all program requirements. Details on each protocol are provided in Parts 2 and 3 of this webinar series. For each building component addressed in this document, a set of protocols has been defined using a standardized system and nomenclature. The standard elements of the protocol for each component are as follows. The first element is the type of testing protocol. The type of inspection or test required is listed in this section based on a standardized set of options as follows. Visual inspection. If this is checked, it indicates that the conditions can be inspected via direct visual inspection of the existing condition and documented with detailed photographs. If taking photographs, photos of faceplates, fixture type, insulation type and depth, etc., must be clear enough to read what is being checked. For example, reviewers should be able to read model numbers from the faceplate, GPM ratings from faucets, and the ruler showing insulation depth. Also, the file name of each photo should clearly identify the building component and its location in the building. A Microsoft Word-based photo template is available to facilitate photo documentation for those protocols that require it. It must be submitted to the EPA at the end of the project. However, once a licensed professional has submitted 3 photo templates to the EPA for buildings that have earned the ENERGY STAR, submission of the photo template is no longer required for that individual. Data sheet. This is used for elements such as mechanical equipment and appliances, where an itemized schedule with proof of delivery or installation is verified through visual inspection, and relevant performance data is recorded from nameplates and manufacturer's specifications. The T&V worksheets have templates for this data collection and are demonstrated in another webinar. Test procedure. This indicates that elements can be verified for proper performance by running a piece of equipment through a standard operation cycle, verifying correct operation of specialized controls, etc., and that the test can be performed without the need for a third-party commissioning agent. Instrument and measurement. If this is checked, it indicates the need for specialized diagnostic equipment to verify the performance of specific elements. For example, a blower door to measure envelope leakage. Third-party commissioning. If this is checked, it's likely that special expertise is required and that a third party will be needed to verify compliance. The second element of the protocol is the performance specification criteria. This section lists the actions to be taken during the design, bidding, and construction phases of the project to ensure that the performance requirements of the building components are included in bid and contract documents so that subcontractors are properly informed of their responsibilities and expectations. All requirements listed in the performance path or prescriptive path must be incorporated into the construction documents. You should clearly identify who is responsible for proper installation and construction. In addition, contract language is suggested in this section that can be included in the construction documents to ensure that the GC is aware of his or her responsibilities in facilitating the inspection process. The third element of each protocol is the procedures and documentation section. This section lists the steps to be followed to ensure that each building element is inspected at the appropriate time and that the necessary data is collected and documented in the T&V worksheets and, if applicable, for use in the as-built energy model, or to prove that the requirements of the prescriptive path have been met. The fourth common element of the protocols is the schedule section. Although exact timing of inspections may vary significantly from one building to another, this section identifies the point in construction when a particular inspection or test should take place. The party responsible for the testing and verification protocols must communicate frequently with the developer or GC to understand the construction schedule and be available for inspections when necessary without slowing down the construction process. The fifth element lists the responsible parties. This section identifies the potential parties responsible for a specific inspection or test and which other parties need to be available or coordinated with to effectively carry out the inspection. The final element in each T&V protocol is a section on sampling requirements. For building components that are duplicated many times throughout the building, such as windows and light fixtures, or cover large areas or sections of the building, such as wall insulation, the sampling requirements section in each specific protocol identifies the minimum required area or sample to be inspected. If the minimum sample is inspected with a 100% compliance rate, then the inspection process is complete. If a failure is detected within the sample set, corrective actions must be implemented and the sample retested in order to be compliant. In general, the testing and verification protocols that follow sampling follow RESNET sampling protocols, as opposed to requiring inspection of 100% of the installed components. For a full description of RESNET sampling protocols, please refer to RESNET's 2006 Mortgage Industry National Home Energy Rating System Standards, Chapter 6. However, the intent is captured in the following sections. Section 603.7.1. A complete set of sampling controls shall be performed at a minimum ratio of 1 test or inspection out of 7 spaces or apartments within a given sample set, per the sampling rate requirements below. The sampling controls can be completed collectively on a single space or apartment, or distribute the tests and inspections across several spaces or apartment within a given sample set, provided that the total number of individual tests and inspections meets or exceeds the minimum ratio set forth in 603.7.1. For example, in a set of 7 apartments, all inspections for insulation, windows, and air leakage can be conducted on the same apartment and lead to compliance for all 7 apartments in the sample set. Alternatively, one apartment could be inspected for insulation, another for windows, and another for air leakage, and could also lead to compliance for all 7 apartments within the set. 603.7.3. To qualify for sampling in a metropolitan area, a builder shall first complete, without any incidents of failure, a complete set of sampling controls on at least 7 consecutive apartments in that metropolitan area. For this initial phase of testing and inspection, the complete set of sampling controls shall be performed on each of the 7 apartments. For example, in a 100-unit building, each T&V protocol must be successfully met in 7 apartments before sampling can be used in the remaining 93. If a builder has completed the protocols in another building in the same metropolitan area, sampling can begin right away without the 7 consecutive apartments. 603.7.6. When an initial failure occurs, the failed item or items shall be tested or inspected in 2 additional spaces or apartments selected from the same sample set. Testing and/or inspections for any items that may become inaccessible during the construction process, such as wall insulation, must be timed so additional testing and inspections can occur on other spaces and apartments in the sample set before they also become inaccessible for testing or inspection. 603.7.7. When an additional failure occurs in one or more of the 2 additional spaces or apartments, the failed item or items shall be tested or inspected in the remaining 4 spaces or apartments selected for the same sample set. 603.7.8. Until the failure is corrected and identified in all failed spaces, none of the apartments or spaces shall be deemed to meet the threshold or labeling criteria. 603.8. Action is required if 3 additional failures occur within a 90 calendar day period. The required action depends on whether those additional failures apply to the same failed item or various failed items. Action could mean suspension of sampling and requiring testing and inspection of all units. Let's review what's required for a statement of substantial completion. Not all of the testing and verification protocols need to be conducted by a third party. Some can be completed by the installation contractor themselves or another qualified representative. When submitting the T&V worksheets, a signed statement of substantial completion, or approved proxy, may be attached to the relevant and fully completed worksheet. When submitting a signed statement of substantial completion, the project's licensed professional who is signing the EPA submittals is still responsible for performing the necessary due diligence to ensure that the statement of substantial completion is accurate and complete. The relevant T&V worksheet must still be completed with all required information, photographs, cut sheets, etc., to demonstrate compliance with the protocol. The actual statement of substantial completion should be on company letterhead and list the project name, address, contact information, and signature for the individual completing the statement, and state which protocols have been met through this approach. If this approach is permitted or required for a given protocol, it will be listed in the Procedures and Documentation section of that protocol. However, the HVAC protocols listed on this slide must be documented using statements of substantial completion and signed by a third-party qualified representative. Now that we have described the basic structure of each protocol, let's introduce you to the many standards referenced throughout the document. The Air Conditioning Contractors Association, ACA, publishes manuals J, S, and D. These manuals provide standardized procedures for completing sizing calculations for heating and cooling systems, manuals J and S, as well as duct system sizing and design, manual D. The Air Conditioning, Heating, and Refrigeration Institute provides an online directory of certified ratings for heating and cooling equipment. The American Society of Heating, Refrigerating, and Air Conditioning Engineers, ASHRAE, developed a ventilation standard for acceptable indoor air quality that is referenced in the Multifamily High-Rise Program for Common Areas. ASHRAE also has a ventilation standard, 62.2/2007, that is referenced for the apartments of multifamily high-rise buildings. ASHRAE Standard 90.1/2007 is an energy standard for buildings except low-rise residential buildings and describes the minimum requirements for the energy-efficient design of high-rise buildings. This standard is highly relevant to the performance path as it describes the efficiency of the building components of the baseline building. ASHRAE Standard 189.1/2009 is the primary source document for the building envelope requirements and minimum equipment efficiencies for the prescriptive path. ASHRAE Standard 160P is the standard that sets criteria for moisture design loads, moisture analysis methods, and building performance and applies to above-grade portions of all types of buildings. ASTM E779-10 is the test method that measures air leakage rates through a building envelope under controlled pressurization and depressurization. This is one standard used to determine whether measured infiltration of a random sample of apartments does not exceed 0.30 CFM50 per square foot of enclosure. ASTM E1827-96, 2007, includes test methods that describe two techniques for measuring air leakage rates through a building envelope in buildings that may be configured to a single zone. This is the other standard used to determine whether measured infiltration of a random sample of apartments does not exceed 0.30 CFM50 per square foot of enclosure. Although not a requirement in the multifamily high-rise program, the ENERGY STAR qualified homes HVAC systems checklists can be used to document the installation of forced air systems in your building. Only two sections of the thermal enclosure checklist are required in the multifamily high-rise program, and only for wood-framed construction. The Illuminating Engineering Society provides the recommended light levels and power densities that form the prerequisites in this program. The data needed is available in their handbook or in the performance or prescriptive path documents. The National Fire Protection Association standards provide guidance for the proper installation of natural gas, Standard 54, and oil-fired, Standard 31, heating systems. Chapter 6 of this standard includes the sampling procedure described in detail earlier in the presentation and in the How to Use This Manual section of the T&V Protocols. In addition to the reference standards, there are pieces of equipment that are highly recommended in order to properly conduct the testing and verification protocols. This is a digital differential pressure gauge. It is used to measure pressure differences between areas, and some models can be programmed to work with a variety of testing devices including blower doors, duct blasters, and pressure and flow meters. The static pressure probe is designed to measure static pressure only by excluding velocity pressure. The pressure pan is a duct leakage diagnostic tool which is used, along with the blower door and digital pressure gauge, to identify air leakage in duct systems. This technique involves placing a gasketed pressure pan over each register or grill with the air handler fan off and the blower door depressurizing the house to a standard reference pressure. A measurement of the pressure between the duct run and the room where the duct register or grill is located provides a quick and reliable indication of whether significant duct leaks exist in that section of the duct system. The exhaust flow meter is designed to make a quick and accurate measurement of airflow through residential exhaust fans and is designed to measure flows down to 10 CFM. The measured pressure can be automatically converted to CFM of flow with many digital pressure gauges. The basic design of a balometer includes an airflow capture device, or hood, and a measurement device, or manometer. The flow capture device is typically a nylon fabric hood mounted over a collapsible frame that directs airflow over a sensing element inside the measurement device. The hood typically has one larger opening that is typically sized to fit a standard commercial register, with other hood sizes available. Most flow hoods can measure flow in both directions, supply or return, and have the capability to perform time averaging. Most flow hoods also have multiple flow ranges that are usually attained by changing the readout device or by using a low flow screen. Having a convenient source of chemical smoke can be extremely useful for diagnosing air leakage sites. The smoke puffer creates a reactive chemical to produce a dense, white, neutral buoyancy smoke that can be used to help identify air leaks during blower door testing. The duct leakage tester is a calibrated airflow measurement system designed to test and document the airtightness of forced air duct systems. A duct leakage tester fan is connected directly to the duct system, typically at a central return or at the air handler cabinet. With the remaining registers and grills temporarily taped off, duct airtightness is measured either by pressurizing or depressurizing the duct system and precisely measuring the fan flow and duct pressure. Duct airtightness measurements are used to diagnose and demonstrate leakage problems, estimate efficiency losses from duct leakage, and certify compliance with duct leakage standards. In the multifamily high-rise program, the standard is 6 or 8 CFM 25 per 100 square feet of floor area, depending on the size of the apartment. Typical apartments would be allowed 50 to 90 CFM 25 of total duct leakage. The standard blower door system includes a single fan, digital pressure and flow gauge, adjustable aluminum frame and a nylon panel, and, if supported, a software program that can be used to download test results to your computer. Typical blower door fans provide quick and accurate flow measurements from 300 to 6300 CFM. To measure higher rates, multi-fan blower door systems are also available. In the multifamily high-rise program, the maximum envelope leakage is 0.3 CFM50 per square foot of enclosure. Typical apartments would be allowed 800 to 1200 CFM50 of leakage, depending on size. Flow plates are designed to provide a simple and accurate measurement of airflow through residential air handlers. The airflow rate through residential air handlers is an important variable in estimating and optimizing the performance of heat pumps and air conditioners. A flow plate temporarily replaces the filter in a typical air handler system during the airflow measurement procedure. If the filter location is directly adjacent to the air handler, the flow plate will measure the total air handler flow. If the filter is located remotely at a single central return, the flow plate will measure the airflow through the central return. Infrared cameras have been successfully used as a building diagnostic tool for over 20 years. From verifying insulation integrity to finding thermal bridging, there is no better tool for diagnosing hidden performance problems. When combined with the blower door, an infrared camera can quickly expose air leakage sites that are buried deep inside ceiling, wall, and floor assemblies. When pointed at a light fixture, an electronic ballast checker turns green if the light source is powered by a high-frequency electronic ballast, and turns orange if the fixture is powered by a magnetic ballast. This indicates a prime opportunity for a lighting upgrade involving electronic technology. ENERGY STAR qualified fixtures won't have magnetic ballasts. Light meters make quick and accurate measurements to verify that required levels of illumination are being provided in a space. Digital thermometers allow precise measurements of temperature. Thermocouples make it possible to measure extremely high temperatures in a variety of situations. Boiler supply and return temperature and cooling water supply and return temperature are examples of the valuable information that can be easily recorded using a digital thermocouple thermometer. A low-E detector is used to check for the presence and location of low-E coating in insulated glazing. Use it to confirm the invisible low-E coating is properly installed in your double-pane insulated glass units. The final appendix in the Testing and Verification Protocols provides additional standards for buildings utilizing flexible ducts in their air distribution systems. We've mentioned two supporting files that have been developed to help document the Testing and Verification Protocols, the photo template and the Testing and Verification Worksheets. The Word-based photo template was designed so that pictures used to provide photo documentation required by the Testing and Verification Protocols could be quickly and easily formatted and consistently reported. This photo documentation must be submitted to the EPA or its designated agent at the end of construction. The photo template only needs to be submitted for the developer's first 3 buildings that participate in the program. Also, if the licensed professional validating documents has successfully submitted at least 3 photo templates, the requirement is waived. The other supporting file is the T&V Worksheets. Rather than create PDF-based checklists, these mandatory Excel-based worksheets have been developed that document the results of plan reviews, inspections, verification, and performance testing. The worksheets follow each protocol, but are organized for the convenience of the site inspector and provide a central file to store building information relevant to all members of the design team, from the architect and energy modeler to the project and site inspector. A separate webinar is available to explain how to use these worksheets. These worksheets are submitted to the EPA both before and after construction. Although Part 1 of this webinar was a general overview of the testing and verification protocols and supporting tools, to improve the chances of a multifamily high-rise building successfully earning the ENERGY STAR, the following tips are offered to program participants. Number 1. As early in the design phase of the project as possible, review the prerequisites checklist. Incorporate the requirements listed in the prerequisites checklist into the design documents and review any unique features of the building that will require special attention in design or construction to ensure that the building meets all requirements of the prescriptive path or meets the performance target once the energy simulations are complete. The performance requirements are listed in the performance path and prescriptive path documents on the website, as well as in the checklists within the T&V worksheets. Number 2. Near the end of the design phase, ensure that all energy-related details are included in the bid documents so that subcontractors are fully informed of the scope of work they are bidding on. Number 3. Use pre-bid meetings to help answer questions and clarify the subcontractor's roles in the successful construction of a high-performance building. Number 4. The developer should specify details to be inspected and conformance criteria in the construction documents so it's clear who is responsible for corrective actions to remedy any inspection failures. Number 5. Use a pre-construction meeting with the developer, GC, and all trades contractors to cover the details to be inspected. Close attention should be paid to those details that are most commonly overlooked in standard construction, including air sealing details, duct sealing details, installation specifications, etc. All parties should be informed at this time of their specific responsibilities for documentation and submittals to the EPA. Number 6. Schedule inspections to occur as soon as possible after construction reaches the point where an inspection of a specific feature is possible. This will improve the likelihood that corrective action can be taken in a cost-effective and timely manner. Inspecting a sample of a specific feature, such as wall insulation in an apartment, near the beginning of the installation of that feature will allow for corrections to be made on installations going forward, rather than causing the contractor to correct improper installations after the fact. Timing is critical for many of the inspections listed in the protocols. The construction process may not always progress in a manner that allows for multiple building elements to be inspected in a single visit. Maintain close contact with the GC and stay up to date on anticipated construction schedules so that inspection staff can be available at the time they are needed on site. In most cases, the sample set for any given feature to be inspected should not be selected ahead of time to help ensure that the inspector is seeing a truly representative sample of the work as it progresses. Number 8. An exception to this would be measures where it may be more effective to have a sample unit prepared for inspection at the beginning of construction, so that corrections to details can be specified for all units going forward. Some possible examples are air sealing details of apartments, some lighting or lighting control strategies, insulation installations, and other special or unique details that are new to the GC or subcontractors. Number 9. For some elements and specifications, it may be desirable to create a mock-up of the detail or conduct a field demonstration to show the GC and subcontractors what is expected for an acceptable installation. Some possible examples include insulation installations, air barrier details, or duct sealing details. Number 10. The photo template and T&V worksheets were not intended to create unnecessary paperwork. They were developed based on feedback from the pilot to streamline the documentation and submission processes and to help design teams be successful from the beginning. By using the same tool to document and report requirements, the design team can use the tool to track their progress and compliance with requirements and then simply submit to the EPA as proof of compliance. This concludes Part 1 of the Testing and Verification Protocols webinar. You should now have a greater understanding of how the protocols are structured and the supporting standards, equipment, and tools that might be needed. Parts 2 and 3 of this webinar will provide greater detail on each actual protocol.